Hi, sir. Good evening.
Good evening, Venkat. Hey, good evening, guys. Three people came today. Okay. Still, sure. Okay, we'll start the class. Let others join. Okay. Mm, yeah. So I think last class we discussed about the timers. Okay, so how to use the timers in FreeRTOS. Okay, how to configure the timer, how to start the timer, and all these things, the APIs which you are going to use in the timers, all these things we saw in yesterday's class, right? So today we are going to see another API that we are going to use here is an queue. Okay, so how to use queue, how to store some data in the queue, how to retrieve the data back. Okay, we can able, for example, if you are connecting any sensors to this RTOS, and if you want to measure some 100 datas at a time, okay, you can use this queue. Okay, you can give the size of that queue as an 100, and you can able to get an 100 data at a time, and you can able to analyze it later if you want. All these things, okay, can be done by using this. So queue, as like you people already know about what is queue and all these things, right? So queue is an, what is queue?
The
What is
queue is
queue?
a type of data, like is a data structure
Okay.
where like variables will be in queue form.
Mm-hmm.
Yeah, and
How this data will be stored?
yeah, one like it is really in stack actually.
Okay.
Yes,
So the data, like which data will come first, which data will enter
first like first in last out. I
first in, last out. No, that is
I'm
for
not sure.
stack. Okay, okay. No issues. Okay, so queue is the data structure. Okay, so data structure means how the data are stored in the memory. That is what called as a data structure. Okay, in which manner or which order you are going to store the data in the memory. That is what called as a data structure. Okay, there is a structured pattern for storing the data. That is a data structure. Okay, so queue is one such data structure where we are going to store and retrieve the data in, first out. Okay, as like how we are in the queue, like whoever enters the queue first has to leave the queue first, right? So that same thing going to be happen here. So the data which we are entering first, that will leave first. Okay, so that is what an queue is. Okay, and here we have a specific set of API for using this in the queue. Okay, for using your FreeRTOS in the queue. So here, if you open this FreeRTOS web page with the APIs and all these things, you will find the queue over here. Okay. So there are multiple queue APIs available like queue create static, queue send, send from ISR, send to back, send to front, receive, overwrite, peak. Okay. All these things are available in our FreeRTOS. Okay. So if you want to send any data to the queue at the last, or if you want to send any data to the queue at front, okay, that you can able to do it with the specific APIs. By default, your data will be entered at last, right? Okay. So here we are going to use as like timer, we are going to use three different APIs. One is queue create, and one is queue send, and one is queue receive. Okay, so we are going to use three different APIs. So first one is queue create. Okay, so in order to create a queue, you just need to give something like an xqueue create. That is a API we are going to use here for creating a queue. Okay, this xqueue create is going to get two arguments. Okay, the first one is the length of the queue. That is how much data you are going to store inside that queue. That is the first parameter. Okay, and the second parameter is the size of each and every data in that queue. Okay, so that is, for example, um, queue. So we already know what is queue. Queue is in first in, first out data structure. Okay, I'm just writing this. We are not going to deal with that here. Okay, so if you want to create a queue, okay, we'll be using something like an xqueue create. Okay, so it is going to ask two parameters. First parameter is how many datas you are going to store inside this queue. Okay, that is the first argument. For example, if you are going to store 10 integer values, okay, in your queue, then what you will do, you will just give something like a 10 comma. This is the size of the individual data. Okay, what is the size of an integer? Size of 4, right? So you'll be giving something like a 4. So there will be a 10 data and size of an each data will be a 4 bytes. Okay, so that is how we'll be creating the queue. Okay, or you can simply put something like size of keyword. Since it is a C program, you can use the size of keyword. You can just give something like an integer or character, whatever it is, what we are going to store in that queue. Okay, that you can able to give. So this is the number of data. This is the size of individual data. Okay, and as like your timer, okay, queue also needs to have a queue handle. Okay, so you just need to have something like an queue handle name. Okay, that is equal to this queue create. Okay, yesterday we created a timer with an handle, right? Something like a timer one or a one shot timer, something like that. Okay, so we'll be creating one queue handle with one variable name. That variable name equal to we will create this queue. Okay, so yeah, we have created the queue. Okay, now if you want to send any data, okay, then the API we are going to use here is xqueue send. Okay, again it will ask two parameters. This xqueue send is going to ask two parameters. The first parameter is which queue I need to send, or actually it will ask three parameters, I think. Yeah, three parameters. Okay, so first one is which queue I need to send the data. Okay, so this is the queue I need to send the data, right? So I'll just give this handle name at first. Okay, as a first argument, right? So that is xqueue sends first argument, the same handle whichever queue you are created. Okay, you can create multiple queues in your program. That is your wish. You can send data to one queue to another queue, something like that you can able to do. Now, I'm going to send the data to this particular queue which you have created. And second parameter is the item to the queue. Okay, so which data you are going to transfer. For example, if you have any sensor value, something like let's say there is some temperature sensor value. Okay, you are declaring it as a temp val. You just need to send that temp val over here. Okay, so that is the second parameter. Handle name That is which queue you are going to send, what data you are going to send. That is the second parameter. And third parameter is something like a tick to wait. Ticks to wait. It is nothing but it is kind of a delay. Okay. Now let's say uh, there are two different things or two different keywords available in the queue. One is queue full or overflow. Okay. And next one is queue empty. Okay. Now, whenever you are transmitting any data to the queue, you need to check whether this queue is full or not. Because if the queue is full, then you can't be able to send any data to the queue, right? Okay, so we need to check whether this queue is full. All right. Now, in data structure, I'm saying not here. In data structure, we'll be checking whether this queue will be full or queue is full before sending any data to the queue. Okay. Now here, the last parameter, first two parameters are okay. Which queue I need to send, what data I need to send. Done. The last parameter ticks to wait is, for example, let's assume you are having a queue of 10 datas. 3, 4, 5, 6, 7, 8, and 10. Okay. Let's say I'm just having something like in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is my entry. Okay. This is how I'm entering. So this is my last queue and this is my first data. Okay. Now I'm actually sending one by one data in this XQSend, right? Now I send this 10 data. Okay. Now my queue is full, right? Now, if I'm trying to transfer the 11th data, my queue will be full, right? Okay. I can't be able to send the data to the full queue. Okay. Now this ticks to wait is, for example, if you give something like 1000 over here, it will wait 1000 ticks, okay, in order to remove any data from this queue. Okay, within this 1000 ticks, if you remove any data, then the 11th data will be sent to that particular place. Okay, or else even after 1000 ticks, if you are not transferring or you are not removing any data, if the queue is still full, then it will return null. Okay, so it will try to send the data to the full queue. If the queue is full, then it will wait for this particular amount of time to remove any data from this queue to transfer. If any data is removed within this time period, then this data will be transferred and it will just wait for another data to be transferred. Okay. Even after this 1000 ticks, if you are not uh, removing any data from the queue and the queue is still full, then it is just going to return something like a null. Okay, that means that data couldn't be able to transfer, or it will, I think it will transfer something like a PD fail, something like that. Okay, I'll check this. Uh, it will either send a PD fail or null. Okay, one of this it will send. Okay, so if the queue is full, then it will send this error message. Okay, or else if there is any space left, it will send the data. So that is what this ticks to wait, the last parameters. Okay, now I have created a queue. I have sent the data to the queue. Okay, if I want to receive the data, okay, so if I want to receive the data, then the API I'm going to use is xqueue receive. Okay. Now inside this, again, it will ask three parameters. First parameter is from which queue I need to receive the data. Okay. So you'll be giving a queue name. Okay. Queue handle name and the received data where I need to store this received data. Okay. So that variable name you need to give over here. Okay, this is for from which variable I'm going to transfer the data and the received data where I need to store it. That is for the receive. Okay, and the third parameter real also I will have something like an, sorry, It is something like ticks to wait. Okay. Now, for sending the data, you are checking whether this queue is full. If it is full, I'll be waiting for this particular amount of time to remove any data from this queue, and then I will transfer the data, right? That is what this last parameter in the queue send. Similarly, in queue receive, okay, if your data is empty or if your queue is empty, okay, then you can't be able to receive any data from the empty queue, right? 6, 7, 8. Okay, you can't able to receive any data from the empty queue. Okay, now again same thing. If I give something like 1,000 ticks over here, it will wait for this 1,000 ticks in order to put any data in this empty queue. Okay, within this 1,000 ticks, if any data has been put in this queue, it will just receive the data and it will store in this variable. Or even after 1,000 ticks, if there is no data present in this empty queue, then it will return the same thing like a PD file or an null or null. Okay, it is going to return that value. For sending a data, we will be checking the full queue. Okay, for receiving the data, we will be checking the empty queue. That's it. Okay, so these three APIs we are going to use here for creating the queue, sending the data to the queue, and receiving the data from the queue. Okay, clear? Any doubts?
Sir, receiving the data, can you once again explain?
Okay. So receiving the data, like how we are transferring the data, the same thing. We need an handle name. Okay, that is which queue I need to receive the data from. Okay, this queue only. Right here only I have stored the 10 data. Okay, I need to receive the data from that queue, and that each and every data has to store in this particular variable. Okay, because only one value will be removing from the queue at a time, right? Okay, so first if this one is removed, then that will be stored in this variable name. Okay, the next one, if there is any other data, that data will be stored in this variable name. Okay, for each and every cycle. Okay, now the last parameter ticks to wait is if there is no data present inside this queue. Okay, then I can't able to receive any data over here, right? In this empty queue. Okay, I need some data that has to be removed and that has to be stored in this variable. If it is an empty queue, then it will wait for this particular amount of time. Okay, this particular amount of time it will wait for inserting or adding any new element to this queue. Okay, it will wait for example, if I give 1,000, it will wait for 1,000 ticks to enter any data inside this queue. Okay, if even after that, if it is not no, we are not inserting any data inside this queue, then it will just return none. Okay, that is what this three parameters are. Clear?
Yes, sir.
Or still any doubts? Okay, others? Any doubts?
No, sir.
Okay, so we'll see the program for that. Okay, so this is queue receive. So we'll be having a queue handle, then the buffer, like where we are going to store the data, and the ticks to wait. Okay, I think this will return. Okay, this is for PD pass.
It returns PD pass if that was
Ah,
successful.
no, that is for the entire queue send. Okay, your queue send will return PD pass. Since it is an X queue send, it will return something, right? Okay, so that is the PD pass.
Hmm.
Okay. If the data is successfully transferred, then this PD pass will come. This text to wait. Okay. So even after this time period, okay, if it is still full, if you couldn't able to transfer any data, new data, then you will get this error queue full message. Okay. And similarly for receive, you will be getting this error queue empty as a return value. Okay. If it is successfully received, you will get PD pass in both. And if you successfully transfer, you will get a PD pass. Okay. If it couldn't be able to transfer or receive the data in both this queue and receive respectively, then you'll be receiving this error queue full or error queue empty. Okay. So that error message you're going to get. And similarly for this queue create also, it will return null if the queue couldn't be able to create for that particular memory you are asking. Okay. For example, you are asking 100 length and 4 bytes of each and every individual item means, then that is a 400 bytes of memory, right? So if the 400 bytes of memory is not present inside this ramp, then it will just return null. Okay, if it couldn't be able to return or if it couldn't be able to create any queue, then it will return null. Okay, so all the APIs, whichever starts with X, it is going to return something. Right, that's it. That is what this X means. Okay, so we are going to create a new project for the queue. Okay, here I'm just going to select the board. Next, and this is my queue. Queue underscore RTOS. Okay, so my program is created, a project is created. Okay, so I'm just going to I'm not going to do anything as of now. First, I will just go to my folder location to copy this free RTOS kernel. 5 members. Okay, no. Too much. Okay, so I have copied that file and I'm just going to paste it here in free RTOS kernel. Okay, so I'm just going to include this to the folder. Play and close and properties, C++ build settings, include path, add workspace, queue. Okay, apply and close. Then I'll get 4 errors. No. Yes. System core, RCC, bypass, still ceramic, sys, timer 3, NVIC, orbit preemption, code generation, system tick, pendable request, and system service. Okay, so I'm just building the code now. I should get 0 errors and warning. Okay. Now I'm just going to copy and paste this ITM code for my printf statement. Core src syscall paste ITM syncer. Paste. Okay. Build. Done. Okay. Done. So now we are going to create a queue. We are going to transfer some data. We are going to receive the data in one task. Okay, we are going to transfer data in one task and we are going to receive the data in another task. Right now, as like your timer, if you want to use this queue, you just need to give something like a queue.h header file. Okay, so this header file you need to add for using any queue APIs in your program. Okay, so now we will just create some includes. First one is my free RTOS. Okay, and the next one is my task.h, and the next one is my queue. Here I'm not going to use any timers, so I'm not using this timer over here. And the next one is it is stdio.h. Okay, so I'm just giving this one for the printf statement. So 4 different APIs. One is for free RTOS, one is for task, one is for queue, and one is for my printf statement that stdio.h. Okay. Now, as like yesterday, we have created an handle for timer, right? Okay. Similarly, we are going to create an queue handle over here. Okay. In my private variable, I'm just going to give queue handle underscore t. Okay. You can give any queue name. I'm just going to give something like an queue. Okay. I'm just giving the same queue as a name for this handle, right? Okay. So after this, I'm just going to go to this user code 2. Okay, here I'm just going to create a queue and two different tasks. One task is for transferring data to the queue, and one is for receiving the data from the queue. Okay, so first for creating a queue, we need an handle, right? So I'm just going to give queue equal to, okay, x queue create. Okay, so there are multiple XQ create like XQ create semaphore, mutex, and normal. Okay, just select this normal one, the last one, XQ create. Okay, and it will ask two parameters. The first parameter is what is the size of the queue and what is the size of an each and every element. Okay, so I'm just going to give something like an 10 queues. Okay, and the size of each and every item in this 10 items is okay, that is the size of an integer, that is 4 bytes. So in total I'm just asking 40 bytes of memory for creating this queue. Okay,
Sir,
yeah,
size of integer depends on the compiler, right?
yeah, that depends on compiler. Here we are using
Okay.
GCC, right? So that is 4 bytes.
Okay. If you want to check how to check, sir?
You can just put a printf statement and check the size of
Okay.
int, you will get a value. Okay, so now I'm just going to check whether this queue is created properly. Okay, so what is the return value for queue create? If it is not properly written, I mean properly created, it will just return null. Okay, so that is what the return value for this queue creators. Okay, so I'm just going to check if my queue, okay, if it is not equal to null, okay, if it is not equal to null, that means it is created, right? Properly it's created. Okay, I'm just going to put a printf statement that says the queue is created successfully. Okay, so the queue is created successfully. I'm just going to give /r/n over here for this data. Okay, yeah, so I have created the queue and I checked whether this queue is created properly, right? Done. Now I need to create two different tasks as like what we did in our first class of the free RTOS, I think second class something. Okay, so same thing, X task create, right? So it is going to ask 6 different parameters. We already know that. Okay, so I'm just going to give first function name as a sender. Okay, this is my, I'll just put q send. Okay, and the stack depth is 200 and the parameter I'm not going to pass anything, and priority I'm just giving it as a 3 and I'm not going to use any handle as of now. Okay, but we will see one example with that. Okay, now this is for one task and the next task is receive. Okay, so receiver, this is for queue receive. Okay, now here I'm just going to give a low priority for receive because initially my queue will be empty, right? First I need to send some data, then only I'll be receiving the data from that queue. Okay, so that's why I have given first sending as an highest priority, high priority, and receiving as a low priority. Okay, or else what will happen? First it will receive, it will go to receive data and it will just wait for the data to be received. Okay, so that problem will occur. So I'm just giving a sending as an high priority and receiving as a low priority. Okay, after this I'm just going to start the vtask start scheduler. Okay, so queue is created and I have checked it and I have created two different tasks and I have started the scheduler. Now I need to put what this two task has to do. Okay, that I'm going to give in the user code 4 as like our previous program. I'm just scrolling down to this user code begin 4. Okay. Here I'm just going to give something like an void. I think it is sender with S capital. Yeah, sender with S capital. Okay, now inside this sender, I'm just going to give then void pointer. Okay, because we know that the task will have the void pointer over here. Okay, now inside this while of one, sorry, while of one, I'm just going to do a particular thing. Okay, I'm going to transfer some data inside the sender queue. Okay, so what is an API for transferring a data? For the API for transferring the data is xq send. Okay, so I'll just type xq send. Okay, this first one. So it is asking 3 parameters. First one is which queue I need to send the data and what is the data and how much tick I need to wait. Okay, so now for okay, for this queue I know what is the name of the queue. That is the name of the queue is queue itself. Okay, that handle name, right? And second parameter is what is the item that is transferred to the queue. Okay, so for that what I'm doing is I'm just going to declare a variable called as int something like a data. Okay, I'll just put something like 100, right? I'm going to transfer this data over here. So I'm just simply type it as address of data. Okay, and comma, if the queue is full, Okay, how much time I need to wait. Okay, if you want to give some number, it will wait for that particular amount of time to receive the data. Okay, here I'm not going to wait for any particular time period, so I'm just simply give 0. Okay, so if the queue is full, it will instantly return the error queue full message. Okay, so that is what this one is. Now we already know this is going to return something, right? You can see over here, it is going to return a PD pass. Okay, now I'm going to check if this queue send, okay, if it is double equal to PD pass, okay, then I'm just going to put a printf statement that the data is transferred successfully. Okay, this is for sending the data. We already know that. Okay, and once this data is sent, it is going to return a PD pass. Okay, if it is PD pass, then I'm just printing the data is transferred successfully, right? If it is not, okay, that means if the queue is full, it will just come out of that, right? Or it will not return the PD pass. Okay, then I'm just going to return something like sorry, I'm just going to print something like printf the data is not transmitted. Or data is not sent, whatever you can just give. Okay, so inside this send data, I have created a variable that is this data is going to be transferred. Okay, now I'm just going to put this data is transferred successfully. If this is not in PD pass, then I'm just going to print this data is not transmitted. Okay, and in order to move from this sender task to receiver task, I need some delay, right? Okay, so I'm just going to give v task delay of something like 1,000. Okay, so I'm just giving 1,000 ticks for it to move to the receiver task. So here I'm just going to create and one more task with I think for receive also I given R capital. Yeah, R capital. Okay, so this is void receiver. Inside this, I'm just giving an void pointer. Okay, now inside this again the same thing, while of one, I'm just going to declare one variable which is called as int r underscore data. Okay, so this r data is nothing but receive data. I'm just going to get the value from the queue. Okay. Now, again, inside the same while of one, I'm just going to first receive this data. For receiving the data, the API is xq receive. Okay. Now, inside this xq receive, it will ask three different parameters. One is which queue I need to receive, this queue. Okay. And the second parameter is the buffer name. Okay. So what is the buffer name I need to give? Okay, or where I need to store this value. Okay, I'm going to store this value in this particular variable, that is r data. So I'm just directly put the address of r data. Okay, and again it is asking how much tick I need to wait if there is an empty queue. Okay, now if the queue is empty, I need to wait for the maximum delay time to receive some data. Okay, because I just want some data has to be entered into this queue. Okay, for receiving it. Now if you want to put some maximum delay, as like we have given something like an port max in C program, I think you people might have given. Okay, max as a keyword in the C program. Okay, similarly, there is a keyword over here, which is port max delay. Okay, so this port max delay is nothing but it is an 8F. Okay, that means it is 32 1. Okay, so 2 power 32, that much amount of delay I'm just giving for this queue receive. Okay, so if this queue receive is again double equal to PD pass. Okay, then what I'm going to do, I'm just going to print that particular data. So I'll just put an printf statement. Inside this, I'm just going to put the data percentage D is received. Okay, so this percentage D is nothing but this R data, whatever the data I have getting from this queue. Okay, I'm just going to put the same data over here. So that is R data. Okay, so now I'll be getting this 100 as a data, right? So here I'll get this data from this queue. So this R data will store that value. After that, I'm just printing the data 100 is received. Okay, so something like that will print. Or else I'm just going to create an else function inside this printf statement. I'm just going to give the data is failed to receive, something like that, slash r slash here also slash r slash. Okay. Now again from this receiver, if you want to go back, then I'll be just giving this v task delay. Okay. So this is again 1000 ticks I'm just giving. Right. So that's it. So first the sender data will transfer this data 100 to this queue. Okay. Now after this, it will go to the receiver data. It will receive the data and it will store in this R data, and that is going to be printed like data 100 is received. Okay. Now I just need to declare this two functions on top of this private function prototype. One is sender, one is receiver. Okay. Yeah. So I'm just going to build this code and check if there is any errors or warning. So there is 0 errors and 0 warning. So now I'm just going to connect my board. Okay. So I think I already built it. So right click, debug as STM32C C++ application. So inside this debugger, I'm going to give this serial wire viewer enable and OK. So switch SPM data console, config port 0, OK, and trace. Okay. So now I'm just going to give this resume button. So resume. Yeah, you can see the queue is created. The data is transferred successfully and data is received. Data is transferred, data is received, data is transferred, receive, transfer, receive, transfer, receive, all these things. Okay. So now I'm just going to do one little change because I'm just getting the same data again and again, right? So I just want to print a different data. So what I will do is inside the center function, this is my data, right? Okay. So after each and every successful passing, I'm just going to give this data plus plus. Okay. So this data will be 100, 101, 102, 103, something like that. Okay. Now inside this SVM data console, I'm just resuming. Okay, you can see first is 100 data is received. Second 101 is transferred, 101 is received. 102 is transferred, 102 is received. 3, 4, 5, 6, 7, 8, 9, 10. It is supposed to stop at 10 because the size of queue I have given is a 10. Okay, but you can see it is like keep on going 21, 22, 23, something like that. Okay, why it is happening? The size of the queue I
It
have
is
given is
automatically removing the
yeah.
queue.
Okay, so the queues never become full here. Okay, I have given the size of 10, but what is happening is first time I am transferring a data and at the same time I'm just receiving the data. Okay, so transferring and receiving, transferring and receiving. So at a time, only one data is present in this queue. Okay, the queue is never full. So that is why it is just keep on moving from 160, something like that. Okay, so now, okay, first try this program. Next, we will just do how to transfer 10 data at a time and 10 data receive at a time. Okay, that we will see next. Okay, first copy this code. So start from the header file. Okay. And yeah, this one. Okay. So let me know once you finish this, then I will scroll to the next line. And also let me know if you got an output.
Sure.
Yes, Yorash.
சார் அந்த STM32 நியூவா இன்ஸ்டால் பண்ணாங்க அதுவும் ஒர்க் ஆகல சார்.
ஒர்க் ஆகலம்மா ஒர்க் ஆகலன்னா
STM
என்ன என்ன ஒர்க் ஆகல?
கிரியேட் அதான் ஓப்பன் ப்ராஜெக்ட் கொடுத்தோம்னா ட்ரான்ஸ்ஃபரிங் த ஃபைல்ஸ்னு ஒரு மாதிரி ரன் ஆகிட்டு அப்புறம் க்ளோஸ் ஆகிடுச்சு, ஆட்டோமேட்டிக் க்ளோஸ் ஆகிடுச்சு.
ஓப்பனே ஆகலையா? எரர் மெசேஜஸ் வருதா?
ஸ்க்ரீன் ஷேர் பண்ணுறீங்களா?
ஓகே.
எரர் மெசேஜ் மாதிரி எதுவும் ஸ்க்ரீன் ஷேர் பண்ணுவா?
Okay, guys, just wait. I'll just stop sharing the screen. Okay.
விசிபிள் சார்?
It's still sharing. The screen is still sharing. I'm not seeing anything. Guys, anyone else seeing anything?
No, sir.
சரியா?
இல்ல வரல. Black screen தான் இருக்கு.
இப்போ
இல்ல அதே black screen.
இது நெட்வொர்க் ஸ்லோவா இருக்குங்க. இப்போ வருதா?
இல்ல. I think இது நெட்வொர்க் ப்ராப்ளம்னு நினைக்கிறேன். அதை செக் பண்ணி பாருங்க. ஸ்க்ரீன் ஷேர் ஆக கொஞ்சம் லேட் ஆகுது லோட் ஆகிறதுக்கு, அதனால அந்த பிளாக் ஸ்க்ரீன். ஒரு தடவை செக் பண்ணி பாருங்க.
Sir, I am facing same issue like yesterday. IOC file is not showing.
Still
Yes,
you
sir.
have updated, right?
Yes, I updated.
Okay, can you just share your screen.
Okay.
Yeah. No, leave it as it is. Don't delete. Okay. Go to help. Click check for updates. Okay, let's wait. Okay, on bottom right, there is one icon, right? Bottom right.
This one.
Yeah, click that. Okay. Let's wait for that to finish.
Sir, when you build the next program, no, can you build on C++, sir?
Okay. I'll do that. No updates found. Okay, so that is dated properly. Okay, now click file. Okay, do one thing. Click file. Switch workspace. Other. Okay, click browse and select any other location or just okay. Just go back in this folder and create a new folder and give anything, something like that. Something like a test or something. Okay, open that folder, select folder, launch. Okay, close this information center. Okay, do the same thing.
இதே மாதிரி தான் சார் வருது இனிஷியலைசிங் வந்துச்சு சார் வந்துட்டு அப்போ மொத்தமாக க்ளோஸ் ஆகிடுது
இது வந்து உள்ள ப்ரோக்ராம் கிரியேட் பண்ணும்போது வருதா இல்ல இந்த சாஃப்ட்வேர் லான்ச் பண்ணும்போது எதாவது வருதா?
கிரியேட் STM32 ப்ராஜெக்ட் கொடுப்போங்க சார் அப்போ
ஆமா.
வரும்போது இந்த மாதிரி வருது சார் அது வந்துட்டு அப்படியே மொத்தமாக க்ளோஸ் ஆகுது அந்த ஐடியே ஃபைலே க்ளோஸ் ஆகுது அப்ளிகேஷனே க்ளோஸ் ஆகிடுது
அப்ளிகேஷனே க்ளோஸ் ஆயிடுதா? So
திருப்பி
ஒரு
இப்போ
நிமிஷம்
uninstall பண்ணிட்டு இருக்கேன்.
Mohammed, just click
பண்ணிட்டு
that first one. No, just type the same F44 and select the first one. Sorry, Yuvraj, சொல்லுங்க. Animation தெரியலையே.
uninstall பண்ணிட்டேன் சார் திரும்பி.
அது ஆக்சுவலி சிஸ்டம் ப்ராப்ளம் தான். ஆன்டிவைரஸ் ஏதாச்சும் வச்சிருக்கீங்களா?
இல்ல சார்.
Sorry. Okay, Mohammed, it's still showing empty. There is no file has been created. Okay, do one thing. Go to help. Yuvraj, now இது முடிச்சிட்டு வரேன் உங்ககிட்ட. Configuration tool. Software package. Okay. So just scroll down. What is the board number? F443, right? Okay. Open
Yes.
this F4. Okay. Click that. Remove. Yes. Okay. Now click it again. No. Click it again and install. Okay. Let it install. And then close this one after it installed. Open it again and then check. Okay.
After this, shall I close it?
Yeah. Once it is installed, then close this. Close your STM cube ID itself. And then again open it and check.
Okay.
Okay. Yeah, I'll check Yuvraj's problem. Okay, you can stop share. Yeah, Yuvraj, screen share பண்ணுங்க மறுபடியும்.
தெரியுதா?
இல்ல.
ஆக்சுவலா இன்ஸ்டால் ஆயிட்டு இருக்கு. அப்படியே கொஞ்ச நேரத்துல வந்துடும் நினைக்கிறேன்.
சரி, ஓகே.
ரவுட்டர்
ஆனா
ப்ராப்ளம்
ஸ்கிரீன் ஷேர்
இருக்கு.
எதுவும் வரல,
ஃபோன்ல
பிளாக்கா தான்
கனெக்ட்.
தெரியுது. ஓகே, மேபி நெட்வொர்க் இஷ்யூவா இருக்கும், அதனால தான்.
ஓகே.
சரி, இன்ஸ்டால் முடிச்சதுக்கு அப்புறம் சொல்லுங்க.
அதுதான் ஃபோன்ல தான் கனெக்ட் பண்ணிருக்கேன்.
சரி. செக். Okay, you can stop share. So others, I'll just share the screen. You can just copy the code.
Sir, this Q hyphen send. So the Q hyphen will removed by compiler itself.
No, this is a string, right? You can give any name here.
Okay. Okay. Okay.
Yeah.
Oh, sorry, I confused this with the sender
Okay,
and
okay.
receiver.
Okay.
We can move down, sir. Others down.
Oh,
Sir, chat close screen share பண்ணிருக்கேன். அந்த yes or no one மட்டும் பார்த்து சொல்லுங்க சார்.
chatலயா?
ம்.
வரல. அனுப்பிச்சிட்டிங்களா?
ஆ
வரலையே.
இன்னும் வரலைங்களா?
சிங்கிள் டிக் வந்துருச்சா?
இல்ல சிங்கிங்ல தான் இருக்கு. நான் க்ளோஸ் பண்ணிட்டு வரட்டும்.
ஓகே.
ப்ரௌசர்ல கனெக்ட் பண்ணி வரேன். சரி இப்போ வந்துச்சுன்னா டிக் வந்துச்சு.
எனக்கு எதுவும் வரலையே குரூப்ல. Have anyone received any message from Yuvraj in group? Can you kindly confirm?
Not for me, sir.
No. Okay. எதுவும்
Yes,
வரல
sir.
யுவராஜ். Yes.
Yes, sir.
Okay, but I didn't receive any message. The last message was from Augustine.
No, I see he sent some screenshots.
Okay, but why I have not received anything? Which group you are? I mean, which group you are sending, Yuvraj? That PG Embedded Batch 1, that same thing, right? Oh, in the chat, yeah. Okay. I thought in WhatsApp. Okay, okay. The .c project file extension is currently associated to unreachable program. Would you like to associate the .c project to the STM-cube instant in use? What error is this? Currently associated to the unreachable program. C: st STM-cube ID, STM-cube ID plugins. Resource project imported Windows project importer.exe. Okay, would you like to associate? Yes, click பண்ணுங்க யுவராஜ். என்ன வருது? Yes, click பண்ணா.
செக் பாக்ஸ் பண்ணவா சார்? என்னவா?
எஸ்
ரிமெம்பர்
எஸ்
மை
எஸ்ஸே
டிசிஷன்.
கிளிக் பண்ணுங்க. இந்த ஓவர் ரைட் அப்படின்னு ஒரு ஆப்ஷன் இருக்கு இல்லையா, அதுல
பண்ணிட்டேன்.
சரி. அதுக்கப்புறம் அந்த பேக்ரவுண்ட்ல இருக்கிறது
இப்போ
ஓகே கொடுத்துருங்க.
மெயின் பேஜ் மெயின் பேஜ் ஓப்பன் ஆச்சு. அதே மாதிரி ரன் ஆயிட்டு திருப்பி க்ளோஸ் ஆச்சு.
இந்த எரர் இதுக்கு முன்னாடி
செகண்ட்
பார்த்தது
டைம்
இல்லை.
அன்இன்ஸ்டால் பண்ணி திருப்பி ஓப்பன் பண்ணேன். இந்த வாட்டி ஒர்க் ஸ்பேஸும் மாற்றி கொடுத்தேன், அப்பவும் ஒர்க் ஆகுது.
அப்பயும் வரலையா? சரி, வேற ஏதாவது டிரைவ் வச்சிருக்கீங்களா சி இல்லாம சிஸ்டம்ல? ஒரே டிரைவ் தான் இருக்கா? சி டிரைவ் மட்டும் தான் இருக்கா?
சார்
சி மட்டும் தான் இருக்கா?
ஆமா.
சி டிரைவ்ல ஆல்ரெடி நீங்க இன்ஸ்டால் பண்ண ஏதோ ஒரு ஃபைல் அங்க இருக்கு, கரெக்டான ஃபைல். நீங்க அன்இன்ஸ்டால் பண்ணாலும் அது போலன்னு நினைக்கிறேன். அதனால தான் திருப்பி திருப்பி இதே வச்சு. வேற ஏதாவது டிரைவ் இருந்துச்சுன்னா அதை இன்ஸ்டால் பண்ணி செக் பண்ணி பார்க்கலாம்.
போஸ்ட் பண்ணி நம்ம இதுல இருந்து நல்லா சேவிக்கலாம்.
ஓகே, ஒன்று பண்ணுங்க. இப்போ 1.19 வெர்ஷன் தான் டவுன்லோட் பண்ணி இன்ஸ்டால் பண்ணியிருக்கீங்க. 1.8 வெர்ஷன் இல்லை 1.7 வெர்ஷன் டவுன்லோட் பண்ணி அதை இன்ஸ்டால் பண்ணுங்க. அது வேற லொக்கேஷனில் தான் எப்படியும் வேற ஃபோல்டரில் தான் எப்படியும் இன்ஸ்டால் ஆகும். ஓகேவா? அதை இன்ஸ்டால் பண்ணி செக் பண்ணி பாருங்க இதே பிரச்சனை வருதான்ட்டு. எனக்கு தெரிஞ்சு இந்த 1.19.0 இந்த ஃபோல்டரில் தான் ஏதோ இஷ்யூன்னு நினைக்கிறேன். நீங்கள் ஒன்ஸ் இன்ஸ்டால் பண்ணதுக்கப்புறம் அப்டேட் பண்ணிக்கலாம் 1.9க்கு, அந்த பிரச்சனை இல்லை. ஓகேவா? இது அன்இன்ஸ்டால் பண்ணுறேங்க முதல்ல 1.9 அன்இன்ஸ்டால் பண்ணிட்டு இதுக்கு முன்னாடி வெர்ஷன் ஏதாவது ப்ரீவியஸ் வெர்ஷன் டவுன்லோட் பண்ணி இன்ஸ்டால் பண்ணி பாருங்க. ஓகே. So Bhagavat, what happened to you? Is it?
Yeah, still it is installing, sir.
Installing. Okay.
Yes.
Okay. Yeah. I'll just do this one more thing. Like, so what happened in our program is I have given 10 data, but still this data is being transmitted and receiving for an infinite amount of time because I'm not transferring the entire 10 data at a time. I'm just transferring one by one data. So one data has been transferred, then one data has been received. Okay, so that is the problem occurs. Okay, that is not a problem actually, but if I want to transfer 10 data at a time and receive 10 data at a time, what should I do? There are multiple methods to do. Okay, just tell any method. I want to transfer 10 data at a time and receive 10 data at a time. In the same program.
While while of data is greater than equal to 10.
நமக்கு என்ன
While of
data
data
வருது
less
okay.
than or equal to 10.
Okay. So the problem is here I know the data is 100. Okay, so I can just check whether this data is greater than 110 or something. But in real time, what will happen? I don't know what data I will get from the sensor, right? Okay, so I can't able to check with the data. Here it will work, but in real time with sensors data, it will not work. Okay, so that method is eliminated. Then
count ஒரு வேரியபிள் போட்டு 10 count வரைக்கும் ரன் பண்ணிட்டு
10 count அப்புறம் என்ன பண்ண போறீங்க? ஓகே 10 கவுண்ட் வரைக்கும் ரன் பண்ணலாம். அதுக்கப்புறம்
சென்ட் ஸ்டாப் ஆகும்.
எப்படி ஸ்டாப் பண்ணுவீங்க? 10
சென்ட் ஸ்டாப் ஆயிட்டு ரிசீவ்.
ஓகே சென்ட் எப்படி ஸ்டாப் பண்ணுவீங்க? கரெக்ட் தான்.
Suspend the task.
Yeah. Okay, so we can able to suspend the task after this 10 count. Okay, so I'll just declare one variable called as count and I can increment that whenever it is reaches greater than 10 or greater than or equal to 10, then I'm just going to suspend this task. Okay, and in receiver again I will do the same thing. After 10 data it is received, I can able to receive this, resume the data. Okay, since it has an highest priority, again this will keep on sending, right? So that is one method. Okay, I'll give you one more method which is an easiest one, or I'll say not an easiest, the most efficient one. This is okay. When I will go to this else part,
When PD fail.
yeah, when it is greater than 10, right? So for 10 data I can easily able to transfer it. Okay, after 10 data or after this queue is full, I'll go to this else part. Okay, so instead of having this count as an another variable and checking if it is greater than 10, I can simply suspend the task inside this else part itself, right? Anyhow, if the queue is full, then it will come to this else part, right? So I'm just going to suspend it over here, and then here inside this else part, I'm just going to resume the task, whatever the suspend task I have given. Okay, is it clear? You can do this with the count variable also. That will work. There is no issues in that. Okay, this method I'm just saying it as an something which is an efficient one. Instead of wasting one variable memory, okay, I'm just doing this. Okay, now in order to suspend any task, I need an this task handler, right? Okay, so I'm just going to this private variable. So I'm just going to give this task handle underscore t. I'll just give something like a t1 for task number 1 and t2 for task number 2. Okay, so now in this task creation here, I'm just going to give something like an t1. Okay, and this one I'm just going to give an handle as t2. Okay, now this is my sender task, that is t1. Okay, so now I'm just going to this else part. Here I'm just giving something like an v task suspend. Okay, it will ask which task I need to suspend. I need to suspend the t1. Okay, then this v task delay should not come because I'm not going to do this one. Okay, or I'm not going to switch to other task. right? So it will send 10 data and then it will suspend. Once it is suspended, it will go to the receiver task. Okay, here it will receive all the datas, right? And it will not actually go to the else part because I have given port max delay. So it will wait for an infinite amount of time.
Yes.
Okay, so I need to give something like, let's say 0. Okay, so I just need to give a else part over here. It will go to the else part. If the data is not available, then I'll just simply put v task resume. Okay, inside this v task resume, I'm just going to resume the task number 1. So once it is resumed, since task number 1 has an high priority, it will directly switch to this sender task. Okay, so that's what I'm planning. Let's say whether it is working or not. Okay, I'm just building it, debugging. Switch. Okay. Happen. This one. Okay, terminate. Suspend operation. Okay, so I'm just going to click resume. I'm just getting some large data, huge data. Okay. Yeah, so first one you can see the queue is created successfully. Okay, after that a 10 data is being transferred. Okay, the data is transferred successfully. It is happening for 10 times. After that, the data is received like 100, 101, 102, 3, 4, 5, 6, 7, 8, 9. Okay, from 0 to 9, 10 data is received. After that, data is not transmitted, that will be printing. Okay, after that, again, it is switching to the sending data. It is transmitting 10 data at a time. Okay, and now that 10 data is being printed, like start from 110 because it is stopped at 109, right? So it is 11110 to 119. Okay, similarly, again, 10 data has been transferred, 10 data has been received. Okay, there is some problem occurred over here, I don't know. Okay, again, this 10 data has been transferred and 10 data has been received. Okay, so this is how we'll be combining multiple things like the suspend task control with some other features. Okay, based on your applications. Okay, now if you want to transfer only some particular amount of datas, okay, like I want to transfer only 5 datas and I have to receive some 2 data, something like it, then you can work with something like this VTAS delay. Okay, here you can give something like a 3000, here you can give something like a 5000. So it will wait for 5 datas to be transferred and it will wait for 3 data to be received. Yeah, something like that, you can work on that. Okay, so this is how we'll be transferring a data and receiving a data from the queue. Okay, you can actually use multiple queues also. For example, here you are transferring in one queue, right? Okay, and similarly, you can receive the data from one queue and you can transfer the same data to the another queue also. Okay, that is possible. Something like you can put Q1, Q2 and receive from one queue and transfer it to another queue. Okay, that you can able to try. Okay, let's try this as an assignment. Okay, get a data from one queue. Okay, and first transfer the data like this 10 data, what we did, same thing. Create one more queue, something like a Q1 and Q2. Receive a data from Q1 and store in a variable and transfer this data to the Q1. Okay, so try that one. Okay, we will see what output you are getting for that. Okay, so for this, if you want to copy this task suspend, just copy this you just have to declare two handles. One is for T1, one is for T2. Okay, that is task number 1 and task number 2, and give that same parameter over here. Okay, and then give this suspect. Okay, copy this.
Sir, still it's not showing, sir.
It's not showing.
Yeah.
Mm. Sorry, I'm speaking with mute. Instead of this 446 board, can you check with some other board? Okay, we will check whether there is a problem with this particular board package or something. Okay, try with that and let me know.
Okay, sir. Sir, same problem, sir.
Same problem.
Yes.
Okay, I'll just check with the forum and I'll let you know. Okay.
Okay.
So from when this problem occurs to you? Day before yesterday or
Yesterday.
yesterday? Yesterday, from yesterday only.
Yesterday.
Mm. Yeah. Okay. I'll check and let you know. Yeah. Have we got output for this? Yes, Vita suspend this 10 data at a time. Finished? Okay, so this is the queue in FreeRTOS. Okay. Yes, sir.
Yes, sir.
Okay, okay. Yeah. So this is in queue. Okay. So the next topic which is left is the synchronization topic. Okay, semaphore and mutex. Okay. So this is one of the most important topics. Like the reason why we are going for this FreeRTOS is like we can use the semaphore and mutex in the task. Okay. Since we are dealing with the parallel processing or multi-threading, synchronization is one of the most important factor that plays in this multi-threading concept. Okay, because let's say you are using three different tasks has to work at a time. Okay, and it is giving some inputs or it is getting inputs and giving some outputs, and one output has to be the input of another one. Let's assume like that. Okay, then there has to be some synchronization between this task, right? First, task one has to produce an output. That output has to be given to the input of task two. It has to process it and give an output to the task number three. Okay, there has to be some synchronization. Okay, even though it is running parallelly. So that is one of the huge task or huge thing that we are dealing with this parallel processing or multi-threading. Okay, so semaphore and mutex is going to dealing with this synchronization between multiple tasks in the FreeRTOS. Okay, so not only in FreeRTOS, semaphore and mutex is actually available in the C++ also. Okay, we can do an
Sir,
multi-threading
I'm working on Linux
semaphore.
also for this
Yeah,
semaphore
for
and yeah.
okay. So anywhere you are dealing with this multi-threading, you will be working with semaphore and mutex. Okay.
Yes.
Even in C++, we are having this pthread, right? POSIX pthread and all these things. There also we will be using this semaphore and mutex. Okay. So we will see this semaphore and mutex. Here we'll be having semaphore as two different semaphores like binary and counting. And we'll be having a mutex. Okay, so for that next two classes, so today is Wednesday, right? Yeah. So Thursday and Friday, hopefully we will complete the semaphore and mutex by this week. Okay, or most probably by Monday. Okay. So what I planned is the next week completely it will be for your project week. Okay, start from this 29th to 3rd of the Sunday. Okay, 3rd of August. So I'll give a project in C++, pick and device driver. Okay, device driver and RTOS, I will combine the project. Okay. Anyhow, you will be getting some sensor value or anything from the device driver, and you just have to work that with an RTOS. Okay. So most probably I will combine this device driver and RTOS in a single project. So mostly you will be having three different projects that you have to do on that particular week. Okay. And after that, from Monday, that is 4th of July, we will start working with what is the next module? IoT. Okay, IoT we will start working with from 4th of July. Right, so that's what I have planned. We'll see what it's happening. Okay, so during this time, I'll be available in the call. So if you have any doubts with the project, you can join and you can clarify your doubts from this 29th to this particular one. Okay, and second and third you can just text me in the WhatsApp. I'll do that. Okay, so that's what we have planned. We will see. So tomorrow we'll see the semaphore and day after tomorrow we'll finish the mutex. Okay, so thank you. We'll see you tomorrow. Bye.
Thank you, sir.
Yeah, thank you. And for Mohammed, I'll just check with this in the forum and I'll let you know. Okay.
Okay, sir, I'm calling you right now on phone. I want to talk to you.
Okay.
Thank you, sir. Bye.
Yeah, thank you. Bye. Okay, thank you. Bye. யுவராஜ் உங்களுக்கும் நான் செக் பண்ணி சொல்கிறேன், நீங்கள் செக் பண்ணி பாருங்கள். I think you went. Okay. Okay, guys. Thank you. Bye.
Thank you, sir. Bye.